The rise of AI agents. Every book, a new way of seeing the world. Hey everyone, welcome to the show. Today we're reading The Rise of AI Agents. AI agents, quantum computing, and blockchain, they're not three separate trends. Together, they're the power trio that's about to reshape everything. Here's what the science says about where this is heading. Part 1. The Iron Triangle of Future Tech. So, early 2026, you probably remember this open-claws lobster fever moment. That's when a lot of people really felt it. AI wasn't just talking anymore. It was doing things. And that's the core idea from today's book. An AI agent isn't just a tool that waits for your command. It's a system that can sense its environment, remember things, reason, set its own goals, and then actually go do stuff. What's powerful about this book is its 3-in-1 strategic framework. Here's the thing. Today, when we talk about AI agents, it's not enough to just talk about AI. The truly powerful agents of the future? They're a fusion, AI plus blockchain plus quantum computing. All three working together. Think of it like a galaxy, each one pulls on the other. They collaborate, they constrain each other. And together, they're going to decide what the digital future looks like. More than that, they're going to decide how we build a future that's trustworthy with actual rules in an age where machine intelligence might pass us by. The author, Peter Radinlev from Oxford and the Alan Turing Institute, this guy's the real deal. He's done stints at MIT, Cambridge, the whole roster. But here's what makes him different. He also spent 10 years as a cybersecurity manager at the Royal Bank of Scotland, and he was the chief penetration tester for the UK Ministry of Defence. So he's not some ivory tower theorist. He's seen what can go wrong. He knows the promise, and he knows the risks hiding underneath. The book doesn't just hype one technology. It steps back and asks the big question. When machines get smarter than us, how do we write the rules? How do we make sure we can trust them? Let's break it into 3 parts. First, the new strategic map of future tech. Then, the security crisis that's already ticking. And finally, how do we write human rules for a post-human future? Alright, part 1. The author's big insight. AI, quantum, and blockchain aren't 3 separate trends. That's old thinking. The real power is in the synergy. Why? Think of it like an elite team with clear roles. First, you've got the autonomous doer, that's the AI agent. Here's the shift. AI is evolving from a tool that waits for instructions to an agent that can sense, remember, decide, and act on its own. 2 breakthroughs made this possible. First one, reinforcement learning. This is how AI gets smart. Simple version. The AI tries things out like a kid learning to walk. No human needs to label every single thing for it. It explores a virtual environment, gets a reward when it does well, a penalty when it messes up. You've heard of DeepMind's AlphaGo beating Lee Sedol? That's reinforcement learning. AlphaGo played millions of games against itself and discovered strategies no human ever dreamed of. That's the proof. AI can break free from human teachers and discover superhuman strategies just by exploring. That's the foundation of an autonomous agent. Second breakthrough, neural Turing machines. This is how AI remembers and reasons. The name sounds intimidating, but here's the intuition. Scientists gave AI an external hard drive and working memory, because traditional neural networks, they're bad at remembering. Ask them to understand a whole novel or execute a 12-step plan, they choke. They can't hold context over long time spans. Neural Turing machines fixed that. Now AI can store information, retrieve it later, and use it to make decisions. With memory, AI isn't just a calculator processing instant tasks. It can understand context, do long-form reasoning, strategic planning. So, reinforcement learning gives it the ability to learn by trial and error. Neural Turing machines give it memory. Put them together and you've got an AI agent that thinks and acts on its own. But an intelligent agent isn't enough. You need a super engine to power it. That's quantum computing. Quantum computing gives AI agents near-infinite computational power. It's an exponential acceleration. The author uses the term quantum supremacy to describe just how insane this is. 2019, Google's quantum computer Sycamore. It solved a specific computation in 200 seconds, a task that would take the world's most powerful supercomputer about 10,000 years. That's not just faster. That's a paradigm shift, a different order of magnitude entirely. When you give that kind of power to an AI agent, its ability to model complex systems and find optimal solutions becomes something we can barely imagine today. Simulating a new drug molecule, optimizing a global logistics network, tasks that take forever today, they could happen in an instant. Okay, now we've got the doer and the engine. Next question. How do we make sure the agent's actions are trustworthy, safe, aligned with our interests? Enter the third pillar, blockchain, the trust anchor. Here's the thing about blockchain. It's a decentralized ledger, distributed across thousands of computers, and nobody can unilaterally tamper with it. That makes it the trust machine of the future. Every key decision an AI agent makes, every transaction, we can write it to the blockchain like a permanent record. It's transparent. Anyone can audit it. No black box. And then there's smart contracts, code deployed on the blockchain that automatically executes when conditions are met. Nobody can tamper with it. We can encode AI's behavioral constraints, risk limits, operational permissions, decision workflows directly into smart contracts. The moment an AI agent crosses a red line, the contract automatically restricts its actions. So here's the picture. Quantum computing powers the agent. The agent executes actions. Blockchain provides the secure, rule-bound framework. None of the three works without the others. That's the iron triangle of the future intelligence system. ## Part 2. The cryptography crisis. Now that we understand the framework, Part 2 hits us with something urgent. The author sounds the alarm. We're on the eve of a massive cryptography crisis. Right now, everything digital that you trust, your online banking password, your WeChat messages, even state-level confidential communications, almost all of it is built on one encryption algorithm, RSA. Here's how it works. Simply, RSA security is based on a really hard math problem, factoring a gigantic integer. For example, I give you 323. You think for a second and say, that's 17 times 19. Easy. But if I give you a 100-digit number and ask you to find its two prime factors, that's brutally hard. Even the fastest supercomputer today would need tens of thousands of years. So the entire security architecture of our digital world is built on one assumption. Factoring large integers is practically impossible for classical computers. But here's the problem. Quantum computers are exceptionally good at solving exactly these kinds of math problems. The book talks about Shor's algorithm. It's like a master key designed specifically for quantum computers. It can factor large numbers with exponential efficiency. And that means the encryption that secures the entire internet, blockchain, and AI communications today could be broken in minutes. Shor's algorithm is like a hot knife through butter for RSA. It doesn't just attack the lock. It removes the foundation the lock was sitting on. And it gets worse. Hackers today are already doing what's called harvest now, decrypt later. They're hoovering up encrypted data they can't crack today, waiting for a powerful quantum computer to come online. At that point, every secure secret from today becomes an open book. The author lays out the defense roadmap, Post-Quantum Cryptography, PQC. We've got to race against time and swap out every lock in the digital world before quantum computers arrive at scale. Two leading PQC approaches. One is lattice-based cryptography. Imagine searching for the shortest path between 2 points inside a 1,000-dimensional crystal structure. The computational complexity is insane, even for a quantum computer. Several of the next-generation encryption standards from NIST, the U.S. National Institute of Standards and Technology, are lattice-based. The other is hash-based cryptography. The security comes from a principle we already know, the one-way nature of hash functions. Like mixing eggs, flour, and sugar into a cake. Easy to do, practically impossible to reverse. That irreversibility gives us quantum-resistant defenses. And then there's a more proactive approach, quantum key distribution, QKD. Instead of relying on math problems being hard, QKD uses the fundamental laws of quantum physics to guarantee security. Here's the intuition. the observer effect in quantum mechanics. If you try to measure a photon, you disturb its quantum state permanently. If a hacker tries to eavesdrop on a quantum key transmission, the disturbance is detectable. The recipient knows the line's been tapped. It's like a letter written in disappearing ink. Anyone tries to open it, the ink vanishes. The recipient gets a blank page and immediately knows something's wrong. That's security based on the laws of physics. It's theoretically absolute security, and it changes everything we thought we knew about encrypted communications. ## Part 3, Rules for Superintelligence. Alright, we've got the framework and we understand the security challenge. Now the big one. Part 3. When a superintelligence arrives, something smarter than all of us combined, how do we write the rules? How do we make sure its goals are aligned with human well-being? This is the classic alignment problem. If we create something vastly more intelligent than us, how do we make it listen? How do we make sure it doesn't just ignore us? The author doesn't just spin scenarios. He gives us a practical framework. The answer is trust plus rules, built in parallel on 2 tracks, technical and social. Technical track first. How do we constrain a superintelligence with code? Blockchain gives us the black box of AI decision-making. Every action is recorded, auditable, tamper-proof. That's trust step 1. But we need active enforcement. Enter smart contracts again. Here's an example from the book. Imagine an AI agent managing a massive investment fund. We encode rules into a smart contract. It can't trade more than 5% of total assets in a single day. Any single trade with more than 2% loss triggers an automatic halt. And any large-scale decision requires cross-verification and signatures from 2 independent AI agents or human overseers. The moment the AI touches a red line written in the contract triggers, restricts its permissions, alerts the regulators. That's a rules framework built in code, reliable, automated, hard to bypass. But technical rules aren't enough. Because a lot of the values we care about, fairness, justice, empathy, these are really hard to define in cold code. That leads us to the social track. The book covers legislative efforts already happening worldwide. The EU AI Act, the world's first comprehensive AI law. It classifies AI applications by risk level. Low-risk stuff like movie recommendations, light regulation. High-risk applications like medical diagnosis, autonomous driving. High-risk applications like medical diagnosis, autonomous driving, judicial decisions, strict auditing. And then there's algorithmic fairness research. Here's the problem. AI bias often doesn't come from the algorithm itself. It comes from the training data, which is just our human history, and our history is biased. A loan approval model trained on past decades of bank data? If that data systematically discriminated against women or minority groups, the AI learns that bias and keeps reproducing it. Algorithmic fairness tries to correct this from inside the algorithm. It adds a fairness constraint during training, forcing the AI to make decisions that don't produce disparate outcomes based on gender, race, or other sensitive attributes. Whether it's the EU AI Act or fairness algorithms, the message is clear. Humans are proactively writing laws for the age of superintelligence, drawing red lines, setting ethical bottoms. And that shifts our thinking from, how cool is this technology, to, how do we govern it? Because the challenge of superintelligence isn't going to be solved by one genius working alone in a garage. It's going to take all of us. Technologists, legal scholars, ethicists, entrepreneurs, and every ordinary person who cares about the future. ## wrap up. That's it for today's deep dive into the rise of AI agents. Let me pull it together. 1. We've got a new map for understanding future tech. The core driver isn't any single technology. It's the iron triangle of AI agents, quantum computing, and blockchain, all working together. Quantum is the super engine. AI agents are the autonomous doers. Blockchain is the trust anchor that keeps it all within rules. 2. We're staring at a global security crisis. Quantum computing is about to make today's encryption obsolete. We need to act now, rebuild the security foundations of our entire digital world. This isn't just a tech problem. It's a survival problem for global finance and national security. 3. The ultimate question: how do we write rules for something smarter than us? The answer is two tracks running in parallel. Technical: use blockchain's tamper-proof records and smart contracts to build a transparent, accountable machine trust system. Social: we need global legal and ethical frameworks that draw the boundaries of human values around AI behavior. Here's the big takeaway. In a future driven by exponential technologies, our biggest risk isn't the technology itself. It's our lagging understanding of it. We can't keep thinking in isolated, linear ways when the world has become interconnected and nonlinear. The future isn't a straight line. It's complex system emergence. Only if we build that systemic, future-oriented mindset, that's how we seize the opportunity and hold the line. So that technological development serves a safer, fairer, more prosperous human future. That's it for today's episode. If you enjoyed this, do subscribe. Every book, a new way of seeing the world. See you next time.